like to talk about serverless architecture a little bit and um, in in how we are using it at my company called Just Fulfill. And this talk is mainly aimed at like software engineers and uh, specifically people who are utilizing JavaScript across the full stack. So basically, people who are building their services and APIs using JavaScript. But hopefully, some of the ideas that I will be sharing, I think it's applicable to any dynamic language, any dynamic programming language you might be working with. Okay, so the idea is like this idea of a serverless monorepo. So it's kind of monolithic by design, but distributed by nature. And hopefully that will become clear what I mean by that. So a little bit about me. So I am the co-founder and technical co-founder at Just Fulfill, and we are an e-commerce logistics startup. So we help e-commerce businesses, e-commerce sellers, basically fulfill their orders. So through maybe you might be selling goods on eBay, Amazon, Shopify, Etsy, and your business has reached to the point that you don't want to deal with the physical aspect. You're getting too many orders. We basically provide services and software to streamline your fulfillment operations. And I also teach at Manchester Codes. You might have heard about us. We are a part-time coding bootcamp based in Manchester. But yeah, due to the pandemic, due to the events, now we are fully remote, and we teach basically JavaScript and React and this type of things. Okay. Cool. So let's begin with the premise of the talk. So the first thing is like, what's a monorepo? So we know that a repository, is basically where we store our code base. And the idea of a monorepo is when a software company is storing different aspects of their business logic in a single code base. So let's say you have this like Letchik software as a service company, and Letchik company does obviously different business functions. So you might be invoicing your customers, you might be producing some reports for your customers, you might have some logic around how you send notifications to your customers mobile phones and emails. So in a usual setup, you might have different like repositories to manage different aspects of your business. You might have a code base to manage invoicing. You might have a code base to manage the notifications. So that's the idea of how you distribute code in a traditional sense. But in a monorepo architecture, what you do is you have like one single repository, let's say on GitHub or GitLab, wherever you are hosting your code, and all the different applications that you run within your business, you put all the code under a single repository, right? So you might have this like one big repo at GitHub, and underneath that you might have some application to manage invoicing, another application code base to manage reporting, some other application code based authentication, notifications, and so on. So many projects are stored in a single code repository, and that's the idea of a monorepo. And this idea is nothing new. It's been used and utilized by lots of different companies. And if you search a little bit about it, you will realize that actually lots of big companies, like big tech companies like Google, Twitter, and Facebook actually have their own monorepos, and they actually build some tool sets to manage this type of architecture. So why would you want to use monorepos? So there are a few aspects which make them like appealing. So one aspect is that it becomes easier to share common utilities and services across different parts of your business. And another aspect of it is that when you need to make some changes to your code base, it's easier to have an oversight on what's happening across all the different departments. So if there's like some changes being made to invoicing, I don't know, the payment gateway integration, people might be aware of that as well, because all the changes will be happening on the same at the same code base. The other upside to having monorepos is this idea that the service boundaries that you have within your business logic, it will be easier to make changes because you can change all the dependencies in a single commit or on a single pull request, basically. So if you have worked with in companies where they are advocating this type of like microservices architecture, you know that you will have most of the challenges there is like, around the network layer, how the communication between different services are happening. So you might have heard this term like consumer driven contract testing. And most of the time when you have this type of microservices type of architecture, it becomes really hard to test the dependencies, like or changing message payloads between different services. So when you opt for a monorepo, you can kind of like make those changes much easier because everything is integrated in one code base. So the other thing is like the end-to-end testing. So when you are trying to test the full scope of your application, it's easier to basically bring up different components in a monorepo setting rather than trying to have lots of mock infrastructure objects that you need to keep consistent and keep up to date. And last but not the least is because you have like one big monorepo, keeping some kind of coding convention and having some stylistic conventions becomes easier to manage and enforce. If you had like 10 different, let's say, JavaScript projects, and if you wanted to have the same ESLint settings across all these code bases, and if they were all separate, you probably need to pull this out to a separate package and publish it and figure out how you keep the versioning consistent across all these 10 repositories. But if you have a single monorepo, your ESLint config could be shared, and you would know that all your projects basically have the same version. Obviously, all these like benefits come, at some expense. So the expense is basically this type of architecture introduces lots of complexities around like building your software, having continuous integration and continuous deployment pipelines configured. So, and that's why if you look into Google's or Twitter's or Facebook's setups, you will realize that they actually have other software. They build other software to manage their monorepo setup, basically. Okay. So, okay, that's enough of me talking. Like, let's hear from, some experience from Google and why, the monorepo, why there's this monorepo architecture at Google. So this is a quote from an ex-Google engineer, Christopher Van Arsdale, and this is how he describes the build system at Google. So the build system inside of Google makes it incredibly easy to build software using large modular blocks of code. You want a crawler? Add a few lines here. You need an RSS parser? A few more lines. A large distributed fault-tolerant data store? Sure, add a few more lines. These are the building blocks and services that are shared by many projects and easy to integrate. So that's the power of basically having this type of monorepo architecture. So obviously all these all these functionality like RSS parsers, web scrapers, I don't know, distributed databases, all these technologies are available, and you could probably open source project that you could integrate with your own software. The only problem with that approach is that every time you want to do something like that, you need to figure out how you are going to bring up this open source project, where you are going to host it, how it's going to talk with your main application, all these complexities basically. Whereas when you have a monorepo architecture, you only need to do that job once, and once you have the logic for, I don't know, having a fault tolerant database, the next time some other application or some other, little part of your business application that needs to make use of that functionality, all they need to do is just like basically import the service, and then off they go. And that's the beauty of having a monorepo, really. Okay, so some people, I know software engineers are very skeptical and cynical people, so they might say, oh, this sounds like a monolith, and monoliths are bad, right? That's what I heard when I was beginning my journey as a software engineer. Microservices was all the hype, and people were saying, oh, monoliths are bad. And yeah, monoliths, get a lot of hate. Why do they get a lot of hate? Well, the main three arguments monoliths get a lot of hate is this idea that they are hard to scale, and people say they are hard to maintain because you will end up with lots of tight coupling between different components of your app. So it will become hard to refactor, hard to basically make changes because they become so large. If you want to refactor, if you want to make a major change, you almost need to be there from the beginning of the application. Otherwise, you wouldn't know all the intricacies and different knowledge needed to make major changes. So, well, I would like to address the first point there, like hard to scale. Right? Monoliths are hard to scale. That's one of the main criticisms. So I think that's a myth, because you could scale your monolith to a very considerable level. So, and the example I want to give is from Uber, and I guess we all know what Uber is. So Uber started their journey with a like a monolithic architecture, like many software startups, and what they ended up doing was like basically up until 2015 they were using this like monolithic architecture, and then they started switching to a microservices or service oriented architecture. And just to have a feel for what type of scale they were able to go with a monolithic architecture, so I looked up the numbers from their IPO prospectus in 2017. So they made about $228 million in revenue in 2014, quarter four or fourth quarter of 2014. And if you take the assumption that average trip is like around $15, that means they were able to service like 170,000 customers per day with a monolithic repo. Right? So they did scale it to I would say a very considerable level. And the reality is many startups don't need to reach that scale. The sad reality is that as well. And if you end up reaching that level, probably it's a nice problem to have. Okay, so another example I want to give on this subject is this New Relic, the company New Relic. So if you are aware of New Relic is basically application monitoring service. So you install their software on your servers, so they can capture the traffic, how your devices are performing, how much disk space you have, how much network traffic you are processing, and stuff like that. So very, very data intensive operation. So this is from the New Relic software engineering blog. So they are saying, oh, we are processing 200 billion plus data points per day, and that's being stored in a Percona server, a variant of the MySQL database. So New Relic is processing 200 billion data points using a mostly a traditional SQL database. They are not using NoSQL, they are not using MySQL, or they are not using NoSQL, they are not using DynamoDB, they are not using anything fancy like that. They're actually using a very traditional SQL database, and they can scale it to the point that they can process 200 billion data points. So I think that kind of shows that this idea that okay, you can't really scale a monolithic architecture. I don't think that's that holds true for most cases. And so the other 2 points, like, oh, they are hard to maintain, or you need to be involved with the project to be able to make major changes since the beginning. I think those two are like valid criticisms, but don't forget, when you're replacing your monolith with a service-oriented architecture, you're actually changing one set of problems for another set of problems, and making like disaster recovery and talking over network boundaries. These are also very challenging problems to work with as well. So just bear that in mind. And okay, but although I talked about monoliths so long, you might think that, oh, I'm going to tell you about a monolithic architecture. Actually, no. So although I'm advocating for a monorepo architecture, our setup at Just Fulfill is not really a monolith. What I call it is it's more of a distributed monorepo. And how that works is that we basically have our API and lots of serverless functions within the same repo, but each like API and each serverless function is deployed and executed individually. Okay. So that's how our repository looks like in principle. So before I began to work on this, I had this dream that, okay, this is how I want to, architecture our application. After reading the, experiences, of Google engineers and reading about monorepos, I decided, okay, we are going to try doing a distributed monorepo, leveraging the serverless framework. And serverless framework, I don't know if you have played with it, it's basically a very popular JavaScript library, which helps you to create serverless functions that you can deploy to AWS, Google Cloud, or Microsoft Azure. So it kind of is a bit like an abstraction layer on top of these cloud service provider serverless infrastructure. So it kind of automates the deployment process, and it's a bit of a code as infrastructure type of library. And so this is how our repository was structured. So we had like this top level serverless functions directory, and within this directory you would have individual serverless functions, like maybe one function to import orders from eBay every 10 minutes, maybe another function to import orders from Amazon every 10 minutes. And at the top level you might have like things like utilities, like some service layer functions, and maybe the database access layer as well. So the idea would be you would share all these top level resources across each of these serverless functions. And when we need to deploy them, they get packaged and they get deployed as part of that serverless function. Okay. Okay, and the usual serverless setup is actually quite different. What you would end up having is, when I was researching whether if anyone else has tried doing something like this, one of my friends told me, okay, we use serverless heavily, but we do it in this manner. So we have lots of different repositories. Each repository has a serverless YAML file, and we, publish shared things in a private NPM package, and database things are service specific. So the idea was that most of the people were creating individual repositories. So like this import eBay orders directory that we have here would actually be a separate repository. On GitHub, this Amazon orders would be a separate repository. You want to share the utils, there's a separate repository. You publish it to NPM, install it, and so on. Okay. So I said, no, I don't want to go down that route. I want to have a monorepo. So there were 3 problems that we had to figure out how to solve. So the first problem is that, okay, how do we package these like top level directories and these top level services and we can inject them into the serverless deployable packages, right? And that was the first problem. The second problem was when we are within the execution environment of a serverless function, how do we reference the top level modules? So that was the second problem. And the third problem was that, okay, well, how do we decide what serverless function to deploy after making a change to, let's say, to the database access layer, or making a change to a utility function that we have at the top level, right? So those were the three problems that we had to solve. Okay. So the first problem was quite easy to solve, actually, because serverless framework has a feature that you can put this syntax in your serverless YAML function. So it can read some files or directories higher up your directory structure. And when it's zipping up and it's zipping the deployable package, it can say, okay, I'm going to copy the package JSON from 2 layers up. I'm going to copy the database module from 2 layers up. I'm going to copy all the node modules from 2 layers up, whatever. So you could tell it to basically include some packages or some directories which are higher up your directory tree. So imagine if you were deploying this eBay function here, you would tell, okay, when you're going to package this repository, this serverless function, you need to read the utils directory and the services directory, or you need to read the package JSON. And so it zips these folders up and kind of injects them to the deployable package. So that was the first problem. So that we solved that quite easy. The second problem was a bit harder to solve. So when you were writing your serverless functions, because at deployment time, different packages will be injected to different. Let me try to word this better. So because, let's say, utils directory is going to be injected into the root level or import eBay orders function. So when you are writing your JavaScript here, you cannot say, okay, just go 2 layers up, because at runtime, there will be a mismatch between the paths. So what we ended up doing was that we used this module called module alias. So this lets you to basically define top level aliases within your JavaScript project. So once we defined top level aliases, we also wrote a custom ESLint rule to basically enforce people when they are writing serverless functions to make sure that they are always using an absolute path, configured by this module alias library. And that way we kind of got around the issue that people might, do the imports. People might do some relative imports within the context of a serverless function, which basically breaks things. Okay. And then the third problem that we had to solve was that, okay, how are we going to decide what we need to deploy, right? The naive solution is that, you could say, whenever you are making a change to the top level directories, you need to deploy all your serverless functions again. That was a bit of problematic in the way that with the serverless framework, what we have experienced is that average deployment takes around 4 minutes per function that you have. And obviously, if you have 20 serverless functions, that means each deployment will take 80 minutes, or that's a very long time to wait for your deployments. So we thought, okay, a better way would be to, okay, let's say you make some changes to the utilities, and this utility maybe, I don't know, maybe it's calculating the tax rate for a given country. And if you are importing orders, we know that, okay, you need to make use of this utility, that you need to calculate the tax rate. So if we could figure out a way to kind of calculate, okay, if you make a change to calculate tax rate utility, that we need to know, okay, eBay depends on that, Amazon depends on that. So we say, okay, now we need to deploy these serverless functions because you have made some changes to the top level. So I wrote a little library in 2008 called Chipper, and Chipper is this like static analysis library, and it basically scans all the JavaScript files in your repository to figure out which file imports which file. So once you do the full scan, we created a graph algorithm at the back of this to figure out, okay, does this library A depend on library B? And it basically calculates this link between two modules, whether they depend on, whether one module depends on another, and it can figure out whether the serverless function is to be deployed using that behavior. So, and the way to use it was like this. We go, okay, run the chipper command, calculate the dependency. So we are saying, okay, does the eBay index.js file depend on the database JS module, right? And then it says, okay, yes or no. And depending on yes or no, we know which serverless functions that we need to deploy. So the last step to figure out was, okay, what does the CI/CD pipeline needs to do? So the first thing that we do is that we always squash and merge all our PRs onto master, which means it's nice and easy to figure out how many files were changed since last commit to master. And then we get a list of changed files since last commit, and then we run the chipper command to figure out, okay, if we change these 20 files, okay, which serverless functions depend on those 20 files. And once you figure out which serverless functions that you need to deploy, we trigger the serverless deploy process that way. And it looks a bit like this in our CI/CD pipelines. So it says, okay, detected 23 module changes since last commit. And so, okay, it calculates which serverless functions we need to deploy. And then we have a separate script which says, okay, it will go through that list and start running the serverless deploy process. And that way, most of the time we can skip deploying, the serverless functions that we don't need to deploy, basically. I have an example here from today that we made some changes to our eBay and Amazon logic. And you can see that here I changed 23 files across like some top level services. And let me show you the deployment process here. So, okay. Just a sec. I need to be on master. Right. So usual steps that you might do on your CI. So we do npm install, and then this is the deployment task, by the way. So it runs this check serverless deployments script that we have, which depends on this chipper library we have built, and it will say, okay, we detected X many changes since last merge. Then it figures which tasks that we need to redeploy. And then we have this other little script which will go through that list and deploy those 4 functions one by one. So yeah, so the total deployment took like 5 minutes for 4 functions there. Okay. All right. Okay. So that's pretty much it. That it was a nice challenge that we set up for ourselves, and we have been running this type of architecture in production for about 7 months now. So we must have made thousands of deployments since then, and it's been working quite well for us. And yeah, so I guess this is very JavaScript specific, but I'm pretty sure that you can do similar kind of architecture with whichever language that you are using. And if you are interested in setting something similar in JavaScript, I would be happy to help. But yeah, apart from that, I'm also on Twitter. You can ask me anything there as well. Well, okay. If you have any questions, happy to answer. Thank you.